Something really neat happens when you graph a function f of x along with its inverse, f inverse of x, on the same set of axes. When you do that, they're perfect reflections of each other about the diagonal line y equals x. This sounds a little strange. Let's do an example to see how this works. Okay, here we have the graph of a function, and we're asked to graph the inverse on the same set of axes. The way you do that is you notice these crucial points here. So we have -4, 0, and up here we have 0, 1. So what I'm going to do is swap x and y. So I'm going to plot, okay, so I'm going to plot 0, -4, and let's do 1, 0. Right, so 0, -4 is down here, and 1, 0 is here. And then we connect those to make the line. Something like this, not entirely straight, but you get the idea. Okay, so this is our f inverse of x. All right, we're assuming this first function here is f of x. And note that we have this wonderful symmetry about the diagonal. I'm putting in the diagonal with a dotted line. Imagine this is nice and straight. Right, there we go. And you can see how these graphs are reflections across this diagonal line. We call this y equals x. Right, the perfect diagonal, y equals 1x plus 0. You can think of it that way. It's a really unique feature of functions and their inverses when graphed together. Let's try another one. Here we go. This function is actually half of a parabola, so it goes through 0, 0, and it looks like we have 2, 4 right here. So 2, 4. Okay, so we're going to switch those points to get the graph of the inverse. Well, switching 0, 0 still gives 0, 0. And then switching 2, 4 gives us 4, 2, which is up here. 4, 2. Okay, and then our graph goes through 1, 1, and up like so. Okay, so if the original graph was f of x, the one we just now graphed would be f inverse of x. Okay, and again we have this perfect symmetry about the diagonal line here, and work that right in the middle, right, and so on. This is y equals x. Y equals x is not part of the graph, but you can see that reflection. Mine's not perfect symmetry, but you can imagine how this would be really nice symmetry here with these graphs. And this will happen for all functions and their inverses. Right? These can get very, very complex when you get into trigonometry and logarithms and all this kind of stuff. But the graph of a function and its inverse are always mirror images across that y equals x line.